All right, so here we are, still in Chapter 6, Summary of Solving Equations. Throughout the course, we've developed a number of different algebraic solving skills, and we're going to practice several different types of them. And basically, this is the way it really works when you are solving a problem. They're not usually in chapters and sections and units. You have to sort of pull together everything that you know. So the first one says solve for h, and you have to recognize that that means there's multiple variables in the question. Currently, it is solved for a. Our job is to get h by itself. So in order to do that, I'm first going to get rid of that 1/2 because that's going to be difficult to work with. So the reciprocal of 1/2, I'm going to do times 2 over 1. You'll notice that times 2 over 1 on the left, I just wrote times 2 because it means the same thing. So on the right, I will have the b and the h remaining, but on the left, I'll have 2a. And if I'm solving for h, you might want to highlight this or underline it just to remember. I'm going to divide both sides by b in order to get h by itself. And then I would have h equals 2a over b, and then I'd be done. H is alone. The right-hand side is as simplified as it can get. I don't have a number in the numerator and a number in the denominator that could simplify. All right, for b, solve for x. So we are trying to get x by itself. So I'm going to look at the left side and say I can't divide both sides by x because the right-hand side doesn't have an x in every term. So I'm going to distribute first. X times 2x is 2x squared minus x equals 2x squared plus 5x minus 12. Now, as far as shortcuts go, if you notice that there's a 2x squared on the left and a 2x squared on the right, and you go to subtract 2x squared from both sides, they are going to cancel. And that would be an acceptable notation as far as I'm concerned for saying, yep, I've subtracted 2x squared on both sides. Now, I'm still trying to get x by itself, so I want to get all the x's to the left. So I'm going to subtract 5x on the right, subtract 5x on the left. That leaves me with only x's on the left, negative 6x equals, and then a minus 12 on the right. And then in order to get x alone, I would divide by negative 6, divide by negative 6, and get x equals 2. So solve for x. I only had x's in the equation. Basically, they're saying find the value of x. Solve for y. So this one has x's and y's. That means I'm trying to get rid of everything on the left side except for the y's. So I'm going to start by subtracting 3x on the left and subtracting 3x on the right. So I'm going to have 6y equals negative 3x plus 24. Now, most of the time, you would not want to divide by 6 if everything on the right was not easily divisible by 6, but it's the only choice. It's the only way to get y by itself. So divide by 6, divide by 6. Y equals. Now, negative 3 over 6 will simplify to negative 1/2. So y equals negative 1/2 x plus, and 24 divided by 6 is just 4. On the right, 2 minus 3 distributed equals negative 6x plus 5. I'm going to get rid of that 2 first so that I can then make a best choice about what to do with that negative 3. Because it is possible to distribute, but as I'm noticing over here on the right, I've got a negative 6 and I've got a 3, which are both divisible by 3. So I'm going to divide the whole left side by negative 3, divide the whole right side by negative 3. Those will cancel. You've still got 2x minus 1 equals negative 6 divided by negative 3 is 2, or 2x. 3 divided by negative 3 is minus 1, and you'll notice that we've got a left side that is identical to the right side. And so we can say we know the solution is all real numbers and be done with that one. After that, solve for x. On this one, I am noticing that I would want to divide by 2, but on the right, 3 isn't evenly divisible by 2. I've also got quite a mixture of variables, so I don't know if that would help or not. So I'm going to distribute the 2 on this one. So 10x plus 2z, you might put that little slash through the z just so it doesn't look like a 2. And I'm going to just check again. I'm solving for x. So I want to try to get x by itself. So I might subtract 2z from the left and subtract 2z from the right. There's no right place to put it because there are no other terms with z's. So 10x equals 30x. Plus 3y minus 2z plus 10. It just goes into the mix because there's nothing else to combine it with. I'm still trying to get x by itself. So I would subtract 30x on the right to get rid of the x's on the right, bring them all to the left. Negative 20x equals 3y minus 2z plus 10. Now, remember before when I was like, well, you know, if the right side's not all divisible by, in this case, negative 20, you might not want to. But in order to get x by itself, I don't have a choice. I have to divide by negative 20. And nothing is friendly to divide by negative 20 except maybe the 10 because it would be negative half. So what we're going to do is leave it as 3y minus 2z plus 10 over a negative 20 and walk away and say, yep, that looks good. The only other thing, sometimes people don't like to leave a negative by itself down here. You might see people distribute that negative up to the top and have positive 2z minus 3y minus 10 over a positive 20, and they would switch the order so the first term is positive. But there's nothing terribly wrong about the original way we had it, just that there are multiple acceptable ways to leave your answer and that I would need to check for those, for example, when correcting, say, a test or a quiz. All right, this one we are going to solve for solve for x. So if I try to divide both sides by 4x, that's not going to work over here. I definitely need to distribute. So I'm going to go 4x squared plus 4x equals. On the right, I have to do the distributive property. So 2x times 2x is 4x squared. 2x times 5 would be plus 10x. Minus 6x minus 15. That's all 4 of the multiplications that would happen on the right. You'll notice, like I had said before, you've got a 4x squared and a 4x squared. If I subtracted 4x squared from both the left and the right, they would cancel. And if I'm solving for x, I might want to simplify. 4x equals 10x, take away 6x would be 4x minus 15. This is starting to look a little funky. Minus 4x on the right, minus 4x on the left. And you're going to get 0 equals negative 15, which is not a true statement. So this particular equation has no solution. And that's only going to happen when you get down to two constants that are not equal to each other. All right. Next, at the top of the backside, same idea. Because there is a 5 here, I could distribute, but since 35 is so easily divisible by 5, I might go with divide the left side by 5, divide the right side by 5. And the parentheses could be lost at that point. You don't have to have them. Add 3 on the left, add 3 on the right, and you would get x equals 10, and you would be done. If you had chosen to distribute, it would have worked out, and you would have had the exact same answer. You would have had a two-step equation. Wouldn't have been significantly more or less work. Solve for m. Now, this is always going to be one of the sort of Achilles heels. If the variable you're solving for is in the denominator, the first thing you have to do is get it out of the denominator. So I would do times m on the right times m on the left and have am equals f. And now I can solve for m by dividing by a, and m will equal capital F over a, and I would be done. But again, I have to mention that if the variable you're trying to solve for is in the denominator, the first goal needs to be to get it out of the denominator. Option number 2, and some people will take this, instead of a, put a over 1 equals f over m, and then you can solve it like a proportion. So you can do a times m equals f times 1, and then divide both sides by a, and you will get the same answer. So two very legitimate ways to solve equations with the variable in the denominator. All right, next, solve for b. So on this one, I'm going to start by adding 2 to both sides because I want to get that ab term by itself. And then in order to get b alone, I'm going to divide by a. And this is another case where you're not going to do anything to help you by dividing both of them by a. You can actually leave it as 3c plus 2 over a, and that would be done. Last one, solve for w. All right, so I'm going to say I cannot divide both sides by 2. I will start by distributing 2 times v, 2 times minus 3 equals 1. I'm going to distribute that minus, so minus w and then minus 4. Getting w by itself, I'm going to simplify the 1 minus 4 as minus 3 minus w on the right. I'm going to add 3 to both sides. 2v minus 3 equals negative w, and I cannot leave the final answer as a negative, so divide the right by negative 1, divide the left by negative 1, and I would have negative 2v plus 3 equals w, or I can rewrite it so the w comes first, and you would be done. So this basically is just a sample of lots of different potential types of equations. It is called a summary for exactly that reason. You've got a little bit of everything. So hopefully we are good to go, and I will see you in class. Bye.